Welcome everyone to the Rancho Mirage Library and Observatory. My name is Eric McLaughlin. I am the astronomer here, and today we're going to be taking, well, not one, but quite a few trips to Mars in a little quick examination of all our robotic explorations to Mars. As we're getting set up, I want to give a special thanks to a few people. First and foremost, a special thank you to the Rancho Mirage Library and Observatory Foundation. It is through that foundation that we are able to actually have these events here. Another special thank you is to Ron Treat, one of our docents, who actually put together a lot of these slides and made a good strides for us getting this able to be out in front of you as well. And a special thank you as well to our new summer intern, Annie Poi, who also made some slides for us here. And finally, a thank you to Jim and Dana Melton of the Mars Society, who actually gave a little bits of information that were nice to be able to put into this one. So we'll jump right in. Yes, we're talking about the actual robotic explorations we've done on Mars here. This is going to be a major overview of all of these things, so we will not have a lot of time to dwell on a lot of different things. We won't go in depth into each of these rovers as much as I would like, but many of these different missions, you could spend a lot of time, multiple talks on just one mission. So again, this will be a nice overview of a variety of things. But before we jump into the actual missions, first, we should talk about where they're going, in particular, Mars. Mars is a wonderful little planet. It is actually the second smallest planet after Mercury, and it is named after the Roman god Mars, for good reason, because it is a red planet. That red comes from the actual rusty color of the surface there, but it was named Mars because, well, the Roman god of war, there's a lot of blood in war, and so the actual red color is what referenced to the ancient Romans and Greeks as blood. So that is how it got its name. Fortunately, it's not blood, it's just rust. But that, as a relatively small planet, its surface gravity is about 38% that of the Earth, and it has an incredibly tenuous atmosphere. Having worked in manufacturing that needs vacuum chambers, I can tell you that getting down to 0.6% of the Earth's atmospheric pressure takes a lot of effort here at relatively close to sea level. So, if you were there on the surface of Mars and you were exposed to the outside air, it would really just feel like a vacuum. So 0.6% is very, very tenuous, but it's still important nonetheless. We'll talk more about that as we get going. And that atmosphere itself is mostly carbon dioxide with a few little trace amounts of other things. And very importantly, it's really hard to get there. Actually, about 50% of the missions that have been sent over there didn't quite make it. And by didn't quite, some didn't even make it off the pad, but some didn't make it as soon as they got there, so we'll talk about a few of those. But nonetheless, we should also ask the question of why should we explore this place? Good answer is, well, of the actual planets that are out there, it is relatively easy to colonize. It is a bit further than the moon, but it is still nonetheless relatively close by, and it has a few things that are very similar to Earth. In particular, its days and seasons are very similar. The seasons are twice as long, but the days are only about 40 minutes longer, which means a given human day-night cycle, their circadian rhythm, can pretty much continue working like normal there. It's a little bit off, again, with that 40 minutes, and there are some NASA scientists who work with some of these missions there that have been on Martian time, and they know some of those effects firsthand. But this place also has a lot of good materials there. There is clear evidence for water ice and a lot of other materials, again, with all that rust. There is, therefore, a lot of iron there. So there's a lot we can actually use there. And it is also really close to another source of natural resources, the asteroid belt, and this can actually help make it a good literal ground base for addressing things in the asteroid belt. Also, it actually can be reached relatively frequently. We have a nice nearly 2-year alignment with Mars, and as such, we can launch things there relatively frequently, about once every 2 years, a little over that. But still, it is relatively easy to get to compared to somewhere like Jupiter or Saturn and beyond. It also may have had life. There's a lot of evidence, as we will find out through some of these missions, that there may have been a lot of water on the surface of Mars. There's good evidence for that, and who knows, maybe there might be little pockets where it could persist. We'll have to go there and find out. And then finally, as is referenced in many different things, including John F. Kennedy's wonderful speech about going to the moon, we choose to go to the moon because it is hard to get there, and also he would reference the fact that it's just there. It's there, it's worth getting to, and as humans who really have a wonderful curiosity about getting to these things, we have an opportunity and a spirit of exploration to get to them. And if you're paying attention, 3 of those words will come up later. All right, so why robots? Well, there's a good reason to not go straight from Apollo to launching people to Mars, and that is because it's expensive. It's also very difficult, but the expensive side of it is that, yeah, we want to launch a unmanned lander there. It might cost about $400 million. That is expensive, but it is nothing compared to an actual manned mission to get there, which would be likely over $6 billion. Again, when you're comparing a few different things, $6 billion in some estimates is actually a pretty low estimate, so yeah, it might be a lot higher than that. But additionally, robots don't eat anything, they don't breathe anything, they just need a power source and a few other things to keep going. And it's nice to use robots in that regard. And they can just sleep for weeks at a time if needed, because there are certain weather conditions that we have to address on Mars. And if you have a solar-powered rover on Mars, there are certain seasons which can be problematic. We'll come back to that as well later. All right, so first, we want to actually go from what we knew of Mars before we ever sent a spacecraft there to our first close-up views. There were a number of things viewed from the ground. We can see all sorts of things, and there were actually things that a man by the name of Schiaparelli actually identified as canale, which could be translated canals, or could be translated as channels. People like to translate it as canals and therefore thought there was artificial construction on Mars at the time, and that was a problem. But it took going there to really be able to prove or disprove what was being seen with the canale, and took a few tries to get there. The Soviets tried a bit, and they had a little bit of trouble, but the Mariner program was the first to actually return good, solid images from Mars. Mariner 3 and 4 were the ones that actually made it there in 1964. And Mariner 3 actually didn't make it. Mariner 4, however, did make it there and actually was able to provide a lot of interesting images, and those images amount to about 634 kilobytes of data. You might not be all that keenly aware of how much data actually goes into some things here. For example, this particular slideshow involved about 2 gigs worth of data, where 1 kilobyte is 1,000 bytes, 1 megabyte is 1,000 kilobytes, 1 gigabyte is 1,000, 1 megabyte is 1,000 kilobytes, 1 gigabyte is 1,000 megabytes. So I used over 1 million times the data that this thing sent back just to make the slideshow. That's how much data they sent back. Nevertheless, they were able to actually get a lot of interesting things. Again, the first images of what was actually there, and they were also able to get their first actual pressure measurements showing how tenuous the atmosphere was. And while they were able to get some temperature measurements at the surface with an estimate at around minus 100 degrees Celsius, that's a little bit different than some of the more recent measurements we've been able to get with a bit nicer instruments later on. But nonetheless, a groundbreaking result. So, okay, we also sent more Mariner spacecraft there, and 6 and 7 were actually able to get some even nicer pictures. They also went over a number of other regions on Mars, and they actually got 20% of the surface, which is a good thing because we were able to show that there weren't any canale or canals. There were not any clearly artificial structures on the surface there, but both of them actually missed some really interesting things. A number of volcanoes, in particular, the largest volcano, the largest actual mountain in the solar system, these missed it. Yeah, that is Olympus Mons. Okay, so yes, they were able to get some things, including atmosphere and trace detections there. Yes, those were great little flybys. They weren't trying to get into orbit. They were just passing by, as it were. So we got some good information from these. But we wanted to actually get to the surface as a species, and the Russians were more aggressive in getting there. And in particular, they had a couple of landers that were some good attempts. These two here, Mars 2MV3-3, number 1. It actually didn't quite make it there. It never even left low Earth orbit because there was a malfunction in the upper stage. The second one made it a bit further. It actually had its orbiter go into orbit around Mars and return some nice data from there. But the lander, it actually had a parachute that didn't deploy, and so splat. But did I say it was hard to get to Mars? Because it really is. Now, on this next slide, you'll notice the same picture for good reason, because Mars 2 and Mars 3 were very similar. And in fact, the actual model still applies to both of them, because, yeah, they were actually a very similar design, if not identical in some cases. So it actually made the first soft landing on Mars. It was a wonderful achievement, and it did have a few instruments on there, able to actually measure different things there. In particular, mass spectrometer is a great way to actually figure out what types of chemicals are there, and TV cameras, of course, are nice to actually show what the surface of this planet looks like. It also had a nice little rover called Prop M that actually would be attached to it, and it had little skis to claw its way around, as it were. But while it was successful in landing, and 90 seconds after landing, it started transmitting data, less than 20 seconds later, it stopped doing that. So there's some possibilities as to what may have happened. It may have actually landed during a Martian dust storm, and some winds moving past the antenna may have actually induced a bit of an electrical charge that may have caused some problems with the electronics. So at this point, all we can do is wonder and maybe someday go back and check, and then we can find out. That'll be a long way down the road, though. But moving on to a more successful landing, we have the Viking orbiters and landers. 1 and 2 launched about the same time, and they both had an orbiter and a lander. The orbiter itself was really a good way to figure out what's on the surface and thereby ensure you have a good place to land your lander. And then about a month after getting into orbit, they launched those landers, and they were both successful in softly landing on Mars. So this is the really good successful landing that we were actually able to get more than just 20 seconds of data out of. All right, so what did we actually get from the orbiters? Well, they saw a lot of really interesting things. They saw riverbeds and all sorts of other things that really showed a lot of evidence of water activity on the surface of Mars, but they didn't find liquid water anywhere. So what else did we actually see? Well, we wanted to get something on the ground to actually find out about life there, and there wasn't much luck in doing any of that, but there was a little false positive at one point. They thought they may have found it. Still, further analysis really showed that what was likely going on there was a matter of, well, you're dealing with an entirely different world's chemistry. Some non-biological sources of that chemistry can actually have some outcomes that can look a little bit like life. In this case, again, a highly oxidized Martian soil means it might actually react with some things, so ended up with again, that false positive. But nevertheless, these two landers and their two orbiters were nice and successful. They were there for quite a while. The actual first orbiter lasted 4 years, while the second one about 2, getting all sorts of good data. And the landers themselves actually outlived both of the orbiters, getting a lot of wonderful information that we could actually see the surface of Mars for the first time. And Yes, it was a wonderful success. We had our first real complete maps of Mars. We had a lot of detailed surfaces, including being able to see a lot of potential water activity here, and again, images from the surface. For scale size, that rock there is about 2 meters high. I am not. So that rock there is taller than me. So just to give you a little perspective on that little image. It's a wonderful thing to be able to reach the surface of another world with this setup. But again, 2 little points where we can actually see a nice little view around. Well, if you've ever wandered around Google Maps and found 3D panoramas, an individual 3D panorama without being able to move around only can tell you so much. So of course we want to go back there with other things, and it took a little while, but eventually we sent Pathfinder there, and it landed in 1996, right near the end of the year, it launched there, and it landed on July 4th the following year. So it went from a holiday season to landing right on a holiday there in 1997, and this particular place was named in honor of Carl Sagan, who was instrumental in a number of these things, especially the Viking lander. It was around this time that he actually passed away. But the Pathfinder lander was really wonderful in that it also had the first rover, Sojourner. That little box right there actually went along with it. We were actually able to see quite a few little exploration there, and we tested a lot of different things, including landing via airbags. You can actually see the airbags all around this here. So it was able to get a good number of good things tested out for the future, hence the reason it was called Pathfinder, to help us find a path by which to land more things on Mars. But it still also did some other things. It was actually able to look at the atmospheric studies through a number of other instruments, as well as, in general, look at the climate and geology. Again, geology might actually be a weird word because geo references Earth, but this is Mars, so Marsology? Anyway, that's beside the point. But this mission actually was intended to only last on the surface for about a week. It went way longer than that because, they were very careful with the use of it and the design of it, and thus well beyond 10 times the actual warranty there, which is great. Now, I'll talk more about that landing technique in a minute because, again, as a pathfinding mission, it was used later. I want to talk more about the little rover, though, because Little Sojourner was a wonderful little thing. It actually had its own spectrometer on it, so it could actually study what the things that were there were made out of. There was a nice little interesting rock you want to go take a look at, so yeah, you go over and you actually get a little bit of that material and you pass it through that spectrometer to figure out what it's made of. And it's interesting what was found. In particular, they were able to find out that there's some things such as iron oxyhydroxide, which is a nice combination of iron and oxygen and hydrogen, and the actual setup there is a good indication of a warmer, wetter past because it's the kind of thing that could form in a wet environment. Also, there was some lightly magnetized dust that is very much so familiar to us here on Earth. The actual straight-up rust, that is ferric oxide, Fe2O3. We'll find that in a few places. It's a nice aesthetic choice out here in the desert. You might have seen it a few places, like on the observatory. That rust there is, again, here, it won't be a problem for all the stuff wearing away underneath it, but there, it's everywhere. All right, so after that, we wanted to get there faster, better, cheaper. This was a doctrine by which we wanted to send a lot of spacecraft to Mars. And what you actually found there is, with regards to robotic exploration, we want to build and deploy these things rapidly. We want to get a nice, perfect design, and we also want the lowest bidder to do so. This creates a little problem. The doctrine of faster, better, cheaper got a nice little amendment a bit later. It was faster, better, cheaper, pick 2. So, as a result, there were some nice things that did come. Yes, Viking and Pathfinder were great, but 1999 was not so good because both the Mars Climate Orbiter, the one on the top up there, and the Mars Polar Lander failed at this point. difficult to get to Mars. One of these ones I always feel like is worth pointing out, and that's the Mars Climate Orbiter. It failed to land, or failed to go into orbit because of a conversion factor between metric and English units. If they had just used their metric all the way through, this would not have been a problem. And that's one of those big lessons that is constantly learned in a variety of places. Anyway, I can rant about metric all the time and how we should be using it, but I won't. All right, so with regards to the Mars Polar Lander, this was a great little instrument that actually was going to land in the polar regions and actually study the ices up there and some other things, but it had an issue with its landing thrusters, and they shut off a little early. So, splat. But after that, we actually had some good successes actually show up, and in particular, we have the Mars Exploration Rovers, Spirit and Opportunity. These are wonderful little rovers. They were launched in 2004. Spirit landed in a crater on January 4th of 2004, often referred to as an interplanetary hole-in-one because it's a relatively small little crater and it just bounced right into it. Opportunity landed on a nice plane that was actually on the complete other side of the planet, but it's worth understanding exactly how these things landed. Again, I said Pathfinder landed with airbags. These ones did as well. So what does that actually look like? Well, when these things came up to Mars, they didn't bother going into orbit. They just released their cruise stage and went straight on in. This is a wonderful case of how the Martian atmosphere is important to address because, well, if you don't, you burn up. So you actually want to use that to slow you down a bit. And after you slow down, yeah, you can go ahead and deploy yourself a parachute. That will slow you down a lot more. At this point, you can get rid of that little heat shield there, which should come in just a second. I'm talking too fast on this one. There it is. All right, so there's our nice little container holding the rover. At this point, there's a problem, and that is that the parachute will never slow it down enough. So as it heads on down to the ground, this is where those airbags will come into play. On that little capsule, you inflate it up really nicely and float right down to the ground. Use some retro rockets to take care of the rest of that and bounce on in. So when we're talking about an interplanetary hole-in-one, it just so happens that this bouncing landed it right in a little hole on a little hole on Mars in a little crater. So wonderful thing to reference out here in a land of golf here. So yep. It did take quite a little while for these things to stop because this shows actually the level of reduced gravity we have there. It takes so long they skipped it. And then eventually, as it settles, they then would deflate those airbags, and then it would just open up with little pedals. Doesn't matter which side it landed on because the opening of those pedals would self-orient the whole thing, and there's a nice little rover in a nice little rover version of the fetal position. All right, so this is a great example of how you can actually land something on Mars. It takes a lot of effort to do that, and fortunately, both of those rovers actually landed successfully by this method. So, how'd they actually get their names, though? That is worth talking about. Again, they're Spirit and Opportunity, and there was one person in particular who was really responsible for naming that. That was Sophie Collins. She actually won an essay contest, and the actual story of this is really neat because she was in 3rd grade at the time, and she was actually a Russian-American student, and her words are worth actually going through. I used to live in an orphanage. It was dark and cold and lonely. At night, I looked up at the sparkly sky and felt better. I dreamed I could fly there. In America, I can make all my dreams come true. Thank you for the Spirit and Opportunity. So it's a neat thing to actually see how these two rovers got their names, and they really lived up to them. In particular, Spirit was on the surface operated from 2004 to around 2010, and it actually functioned 20 times longer than its 90-day mission. This is a nice pattern we actually start seeing here. So it actually only was planned to go 600 meters, but logged about 7,730 meters. So it was looking around for more water-related processes, similar to what was hinted at through what we discovered with Pathfinder, and these discovered a lot of wonderful things. It also was looking at Martian geology to see if there was more that would be conducive to life, and yeah, we start finding some evidence, again, of that really keenly noted wet past of Mars. We see a lot of different things there, but it traveled quite a different ways. This is a view of a significant amount of its drive. It started over here at the Columbia Memorial Station, so named after the Columbia shuttle that broke apart on re-entry. But this view on the left is actually looking down this way, and you can actually see the Columbia Hills complex here, which is where it spent a lot of its later years. It actually wandered around over a place called Home Plate and a number of other things. What did it actually get? What actually ended up happening with this little rover, though, was eventually it had some issues with its wheels, and it got stuck at one point and was for quite a while deemed a stationary research station on Mars. It worked quite a little while thereafter, but eventually in 2010, on that March day, it sent its last signal, and we did not hear from it since. But still, it was able to be around for quite a while there. So it was a wonderful, successful mission that helped us learn a lot about Mars itself. Opportunity had a bit longer journey. It had started about the same time, and it actually was officially ended February 19th of this year, though the last signal received was from June of last year. But it still functioned 55 times longer than that 90-day mission that it was planned for. It was actually operating on the surface of Mars for about 5,100 Martian days, or sols as they're often referred to there, here, there, whatever. But it actually went a long distance. It's an outstanding record, actually. It drove for 45 kilometers, which is longer than the distance of a marathon. So this is our first marathon running robot here. It actually took a lot longer than anyone's ever done to run a marathon, but it was busy the whole time, doing a lot of science. Now, if you're wondering about the image on the right, it's worth noting that that is actually simulated from a picture which Opportunity took. Opportunity did drive into that particular part of the frame at one point, but it was computer-generated, put back where it was at another point to actually make this image make sense. This image could have been seen if you happened to be standing next to the rover when it was in that spot, but it was made again a bit later. Anyway, it's always interesting how these things work out. But yeah, that is an actual picture of Mars with the position of Opportunity at one point in time superimposed into it. All right, so it also looked at those water-related processes. It actually also did some astronomical observations. It was able to see some things in the sky, looking at the moons of Mars and other things as well. And it also was looking at that atmospheric data. And as it went so far and did so much, this little rover is often referred to as NASA's greatest robotic achievement. It really was a profound success, operating for so long there. And let's see. And here's an actual overview of a lot of things it saw. Here's a view of what is called Spirit of St. Louis crater, and you can actually see the overall path it took here from Eagle crater to Endurance crater, past Victoria crater, on down to Endeavour crater. To give you a little perspective on what we're seeing here, there is the footprint of Washington, D.C. marked out in blue there. So it drove quite a ways. But this little mission was a wonderful one that really accomplished quite a bit. Here's an actual view trailing off behind it as it cruised on around Mars there. It actually set a number of different records, but when it comes to solar-powered rovers on Mars, there is something that always must be taken into account, and that is dust collection. Over that period of time, yes, dust would collect on the surface of the rover, and we do, again, have to deal with the Martian weather. Martian weather consists largely of sunny or dusty skies for the most part, and there are actually significant dust storms on Mars to the extent that on a seasonal basis, there are often global-scale dust storms, the entire planet enshrouded in a layer of dust. And as such, after all that time, there was, while we were actually taking a look at Mars from this site here, it was approaching our nearest approach to it about this time last year, a little bit later, and we actually were able to take a nice close look at it. We didn't see much because of the actual thickness of that dust cloud, but at the same time, little Opportunity was hunkering down, trying to pull through it, and this image here is actually the last image it actually sent. This one, again, when it came down to its last signals, it was telling us a few things. In particular, it was saying that the sky was getting darker and that its battery was running low. And a particular journalist actually translated that and stated it in a nice personal terms, such as my battery's running low and it's getting dark. And it really tugged at the heartstrings of everyone and made people feel really sad that we were losing this rover. It never did actually regain communication, but nonetheless, it still had a good impact. And whoa, back it up. It went past 5 slides there. Okay, here we are. So this is a lovely little comic called XKCD, and it's always a great idea to see how different missions impact people. And yeah, this is a great sentiment. Some people complain that we see the world through our cameras, but to me, the really exciting part of finding something new has always been showing it to others. Exploring an entire new world would already be the adventure of a lifetime. Imagine having the chance to share every new sight with 7 billion friends. I'm not crying, you're crying. Moving right along, though, to a nice British lander that, it launched it was scheduled to land, rather, on Christmas of 2003. Unfortunately, it was actually declared mission lost in 2004. The lander was actually able to be spotted from orbit with the Mars Reconnaissance Orbiter in 2015. It takes a bit of time to try and spot these things with these instruments because it's really small on the surface of this planet. But nonetheless, they were able to figure out what was going on there, and in particular, these solar panels that were actually on there did not deploy fully, and that's a huge problem because it blocks communication antennas. So yeah, it never was able to do any of that. So its primary mission was, again, looking for those signs of life, but it was named after a neat little vessel called the HMS Beagle. You might be familiar with that. It was the one that Charles Darwin sailed on when he actually went around to the Galapagos Islands and partially formulated his theory of evolution. But just really good reminder, though, in this case that, yeah, getting to Mars is difficult. You get the idea. Anyway, yes, it might be hard to get there, but sometimes things rise from the ashes and get named phoenixes. In particular, we have the Phoenix lander, which actually operated from 2008 to 2010. It was the particular mission that it was rising out of the ashes of was the Mars Polar Lander. The Mars Polar Lander, again, it had issues with its thrusters and flat. So in this case, they actually were able to redo this mission, and as it was coming from that particular case, that's where it earned that nice name. And it was also only intended to last for about 90 Mars days and lasted quite a bit longer for 157. It didn't have the same things that can make certain rovers last a bit longer. The things that can make rovers last a bit longer is actually, in the winter, you can drive up on a little hill, face your solar panels in the direction that they will get the most sunlight. Landers like this can't do that. And so being up at the poles, it got very little sunlight in the winter, and that is one of the things that really caused the end of that particular mission. It's something that was expected, so it was still very, very successful. So this one was also one of the first, or really the first mission that was led by a public university, and it was also, again, the first successful landing at the polar region since they had other failures before. But as the first successful landing at the polar region, it also started showing that there was a nice track record with regards to NASA's run there. The 6th successful landing out of 7 attempts. That's a wonderful result. And as such, they was also able to get a lot more information about the ices and such at the pole. There was really interesting stuff they were able to figure out there. In particular, it was looking again at that geological history of water on Mars, and also was looking towards the future, because when it comes to looking for that water ice, it's also worth going and saying, hey, would this be a good spot for humans to land? And so if we can actually find a lot of water ice there, that is very useful for not only giving us drinking water, but also can be put through electrolysis and give us some nice oxygen by actually pulling that out of the water. And then you also get hydrogen as a byproduct as well. And so, as of course the first thing to land at the poles, it was also the first mission to actually tell us about the water there. And its arm was actually really a unique one that could do a number of different things through its actual versatility and design. It could do more than just scoop little things. It could also manipulate other stuff as well. All right, so still moving right through all of these different things, there's one more really wonderful rover we've landed so far, and that is the Curiosity Rover. It truly is the descendant of Spirit, Opportunity, and Sojourner, because it took a lot of the lessons we learned from those things and put it into a car-sized rover, and it was intended to go to Gale Crater and explore quite a bit there. When I say car-sized, don't think our typical American SUVs. No, this was much closer in size to a World War II style Jeep, like this one, which we actually had here back in January, February time frame with the Writers' Festival. This is Dwight D. Eisenhower's Jeep from World War II. So anyway, about that size is really what we're talking about there, a relatively small car. But getting to the surface of Mars is, again, difficult, and this one being a bit bigger than Spirit and Opportunity, airbags will not have been sufficient, so things had to be developed a different way. And this entry, descent, and landing really sets up for something rather terrifying, often, well, in this particular case, was directly referred to as the 7 minutes of terror. I'll let the engineers talk about this particular landing.
When people look at it, it looks crazy. That's a very natural thing. Sometimes when we look at it, it looks crazy. It is the result of reasoned engineering thought, but it still looks crazy. From the top of the atmosphere down to the surface, it takes us 7 minutes. It takes 14 minutes or so for the signal from the spacecraft to make it to Earth. That's how far Mars is away from us. So when we first get word that we've touched the top of the atmosphere, the vehicle has been alive or dead on the surface for at least 7 minutes.
Entry, descent, and landing, also known as EDL, is referred to as the 7 minutes of terror, because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0 in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
We slam into the atmosphere and develop so much aerodynamic drag. Our heat shield, it heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicle is not only slowing down violently through the atmosphere, but also we are guiding it like an airplane to be able to land in a very narrow, constrained space. This is one of the biggest challenges that we're facing, and one that we had never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use a parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck-snapping 9 Gs.
At that point, we have to get that heat shield off. It's like a big lens cap blocking our view of the ground to the radar. The radar has to take just the right altitude and velocity measurements at just the right time, or the rest of the landing sequence won't work.
This big, huge parachute that we've got, it'll only slow us down to about 200 miles an hour. And that's not slow enough to land. So we have no choice, but we've got to cut it off and then come down in rockets. Once we turn those rocket motors on, if we don't do something, we're just going to smack right back into the parachute. So the first thing we do is make this really radical divert maneuver. We fly off to the side.
Diverting away from the parachute, killing our horizontal velocity and our vertical velocity, getting the rover moving straight up and down so it can look at the surface with its radar and see where we're going to land. And we head straight down to the bottom of a crater, right beside a 6-kilometer high mountain.
Note that dark stripe
We can't
right
get
there.
those rocket engines too close to the ground, because if we were to descend propulsively with our engines all the way to the ground, we would essentially create this massive dust cloud. That dust cloud could then go and land on the rover. It could damage mechanisms and it could damage instruments. So the way we solve that problem is by using the sky crane maneuver.
20 meters above the surface, we have to lower the rover below us on a tether that's 21 feet long, and then gently deposit on its wheels, on the surface.
As the rover touches down and is now on the ground, the descent stage is in a collision course with the rover. We must cut the bridle immediately and fly the descent stage to a safe distance from the rover.
Splat. I love good movie trailers, but I always love seeing the movie more. And so what is wonderful is there was an actual descent camera on this system, so we actually do have a view of what the rover saw as it descended down. It wasn't a fully fledged video camera. There are some good ways of looking at it, but this is the actual really unedited high-resolution footage of that descent. And you can actually hear mission control in the background for this view here. So the chute is already deployed by this point. There goes the heat shield. Remember that dark stripe I said to pay attention to? There it is. All right, still under the parachute at this point. See that divert maneuver in a second once it cuts away. So if you're ever wondering what it looks like to land on another world, this is literally it. All right. And all right, they're about to remove from the parachute. And you'll notice the shaking will go away pretty quickly after it releases. There it goes. Doing its divert maneuver there, tilting to one side. And it tilts back the other way to stop its lateral motion. Now, as it will descend down, you'll see the wheel pop into frame as it does the sky crane maneuver. There's dust getting blown away there. And descending for the sky crane maneuver. There's the wheel. And a lot of dust. And touchdown. You can see a little bit of dirt right there as the dust settles. Wait for it. They're going to figure it out in a second. They still haven't. There's the touchdown. And there's mission control going wild in the background. That is about the timeline of that, though again, this sound is still diverted by that 14 minutes or so that was mentioned in the previous video. It was realigned to actually show, based on the data they were receiving, how they actually were experiencing the time with respect to that landing there. So it was a wonderful, difficult maneuver, and they were quite successful in the landing there, and this mission has been quite a successful one. Again, it was only planned for about 663 Mars days, and it's now at 2,400 and counting. It has been there for quite a while, and it is also, in particular, when it's looking at Gale Crater, it is, you might have guessed it, looking at water. In particular, Gale Crater is a place where it was believed that there was an ancient lake at one point, and there's actually a lot of evidence just from orbit that seems to suggest that. But getting down to the ground, it has actually been able to actually see little shores on the lake and explore the lake bed itself, and now it is ascending up Mount Sharp to explore more on that particular setup there. It also, again, was looking at whether or not it would actually be outright habitable at one point, and that in particular is useful with regards to potential future human exploration. So this little rover has done quite a bit, but it's always, again, good to go back and see where these names are coming from. And in this case, there was a 9,000 entry contest for this particular rover's name, and Clara Ma was the winner of this one, and she was actually a student at a elementary school at the time. Her entry in particular went something like this. Curiosity is the passion that drives us through our everyday lives. We have become explorers and scientists with our need to ask questions and wonder. And so it's with that the notion of curiosity for this rover, the Mars Science Laboratory, really took hold and was a great name for this rover. All right, so this rover's been there a little while, and it's had a number of nice milestones. And to talk a little bit about the science and one of those milestones, we'll let one of the engineers on the SAM project talk about that.
My name is Florence Tan. I'm the SAM electrical lead engineer. I work at Goddard Space Flight Center. SAM stands for Sample Analysis at Mars. It is an organic chemistry lab on the Curiosity Rover. It is the most well-equipped chemistry lab that we've sent to Mars to date. Curiosity landed on Mars on August the 5th, 2012. It was born on Mars that day, and so we consider that day as its birthday. We're here at the testbed lab where SAM is built. It is an identical unit to the unit on Mars. and we use this unit to test our experiments before it is transmitted to Mars. Sam will be running some great science experiments on Mars. We will be analyzing some soil samples. To make the soil samples go down, we had to program it to vibrate at various frequencies. When we're introducing a sample into SAM, it'll go through a resonance and it'll sound like this. To commemorate Sam's birthday and Curiosity's birthday on Mars, we decided to play a little song. If there's anyone listening on Mars, on this special occasion, you will hear this. It's really neat and it's exciting. This is a first for NASA and for the world. And music brings us all together, so this is fun. It's been a great year on Mars, and I cannot wait to get to Mount Sharp next year. We've discovered so many new things, and there's still lots more discoveries to come.
Indeed, those discoveries have been coming. But it's always a lovely thing to me to picture this rover by itself on the magnificent wasteland that is Mars. And there, while the atmosphere is substantially thinner and it might sound a little different, you hear the rover singing to itself, "Happy birthday." It's kind of isolating and sad that it's by itself, but someday we'll get there, hopefully. So, other things it's done. Yes, it has been looking to climb Mount Sharp, and this is a view of it. And here is an actual trail of where it has driven over the years, and it has made its way quite a ways up Mount Sharp already. It won't be trying to drive up this, mind you. It knows which ways are good ways to go, and by that I mean the engineering team are telling it all the ways it should go and not try and drive up steep cliffs. So there are nice routes to take it up there, and they are making some great progress in that. But as far as the actual setup for getting stuff there, yes, this robot is wonderful for actually exploring Mars for a few things. You may have noticed this one doesn't have any solar panels. It is actually powered through a radiothermoelectric generator. Thus, it is using radioactive decay to actually generate heat, which is thereby used to generate electrical power. And when we're talking about this whole setup, it also has a very powerful laser it uses to do science. So how do you explore a planet? Well, you get yourself a nuclear-powered laser tank and you shoot some rocks. So that is how that particular rover has been exploring. And again, it has been very successful in many different ways. The Europeans also, though, have been looking to send stuff to Mars, and in particular, they sent the Trace Gas Orbiter with the Schiaparelli Entry, Landing, and Descent Demonstrating Module, or EDM for short. This particular mission, yeah, again, it's about trying to get to the surface and understand how to do so with equipment all built in-house in Europe. And again, its primary purpose was as a test bed to reach the Martian surface. And secondary to that was all the science that it would do once it get there. It just wanted to make sure they actually could make an attempt to reach the surface. So how'd it go? Well, entry into the atmosphere went well. The parachute did deploy, and this is an image actually taken from the high-rise instrument of the Mars Reconnaissance Orbiter, I believe. If I might, yeah, okay, thank you. It always helps when there's another scientist in the audience there. Yeah, so this is what it actually looked like from orbit. Unfortunately, under that parachute, there was a bit of a spinning going on for a brief moment. That spinning actually caused the inertial measurement unit to become saturated. What does that mean? Well, it means the signal in the gyroscopes and other things went so high that it caused some issues. Then some bad things happened. In particular, the saturation led to an actual recorded measurement that was erroneous. In particular, one that said that the spacecraft was 3 meters below the surface of the planet. So what happened next is, okay, let's try and do everything we have to do to land this thing in a few seconds. So it immediately cut away from the chute and then turned on its engines for about 3 seconds. It didn't actually leave the thrusters on for long because it thought it was on the ground. And so they shut off and immediately started doing ground operations, all while continuing to fall and then splat. So this is an actual view of the site itself there. You can actually see magnified in the rectangle here. We actually have the crash site there with the parachute, I believe, down here where that actually reached the surface. So once again, getting to Mars is difficult. The Europeans have learned that here. But again, as this is primarily a test bed for figuring out technologies to reach the surface, and the surface science was a secondary part of this mission, this landing was actually considered a success by the Europeans because they learned a lot. Why? Well, because this system was also transmitting its information all the way down to the ground. So they have telemetry all the way through, so they know exactly what went wrong and how to fix it. And that is really important for their next missions, which we'll talk about momentarily. In the meantime, though, we've actually landed some other things on Mars since this time frame, and one of which was looking at seismology on Mars. That one was the interior exploration of Mars using seismic investigations, geodesy, and heat transport, or InSight. One of those really forced acronyms that are always so fun and all over the place here. But this one was a really useful experiment that actually, or I should say is a very useful experiment. It actually put a seismometer right on the surface of Mars and covered it with a nice little tent, as it were. Tent, I say, it was made of copper, but it actually was to block the wind so it could make very, very sensitive measurements. And so being able to make very sensitive measurements allows us to start to map the interior of a planet. The reason why we know what's going on inside the Earth to a good amount of, to a wonderful extent, is because of seismology, actually measuring shock waves passing through the Earth. And so this helps them do that as well. And of course, also general seismic activity. It also was able to give us some more information on how different terrestrial objects evolve. That's what we're looking for there, I should say. And in particular, it also wants to help us understand the core of Mars. Mars does not have a substantial magnetic field. That is something that is indicative of something going on at the core, possibly a solidification of it that would actually stop the magnetic field from generating. But we don't know that for sure until we can actually get some measurements. So this is one thing that really helps with that. And a minor little Marsquake has been detected there. And by minor, I mean really, really minor. We really wouldn't have felt it here, especially here in earthquake-prone. The earthquake-prone desert, we know what minor earthquakes feel like. This is much more minor than what we would feel. But nevertheless, this one's mission duration is planned for 709 days. It's over 190 sols at this point, and when I say days, I meant Martian days. So it's been around for a while. It should be around for a while more. But this particular lander also has something else on it that's really neat, in my opinion. It has my name on it. Because this particular mission, they have, this isn't anything I actually worked on, I should say. In particular, what this mission had was a nice system by which, if you submitted your name, it would fly to Mars with it. So this is my boarding pass, as it were. Accruing some nice frequent flyer miles there. But this particular program, yeah, it's nice to have a little things referencing people on the Earth. Could be checked out sometime in the distant future. But again, this is the first time they really started making it a long-term thing. So they actually do have a frequent flyer program that you can earn points on. You can't ever cash them in, but you can still note them later on. what comes then after this point is starting to look to the future. And so in the very near future, we have the Mars 2020 rover coming up. And this one still hasn't earned a name yet, so we'll see where they go with that. But it is heading to Jezero Crater, and it is looking at a lot of different things. It is actually looking more at that astrobiology type of thing, in particular, trying to see if the ancient Martian environment did have life. It is something that, again, takes a bit of effort to figure out. We've been looking at this for a while now, looking at water and all these other things. Are they ever going to get a finite answer? Well, yeah, again, it just takes a lot of steps. You can't just figure it out all at once. You got to incrementally, that's the word I was looking for, incrementally work your way to answering this question. So again, we want to see if there was possibility of past life on Mars. And so looking for biosignatures, chemicals that actually indicate past life actually being in these geological formations. But it will, again, we'll wait and see what it actually gets, but it will also do something really neat. It will actually be storing some material that can then be deposited and retrieved for what would be a sample return mission. More on that later. But this little rover, you might think it looks familiar. That's because it's built on a similar test bed to Curiosity. That allows for a lot of different things, including being able to actually build this one more quickly in a number of ways. But it's got a number of different instruments on it: Moxie, Pixel, Sherlock, 23 different cameras, a little helicopter, and also an adaptive caching for samples. Again, that sample return mission. So that's been proposed. All right, so what on earth is all this stuff? Well, you've got the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE. That's an acronym built into an acronym. Anyway, it's intended to actually take atmospheric oxygen, and in particular, carbon dioxide, and use it to try and actually generate breathable air. This is a very important experiment for future missions there, in particular ones with non-robotic passengers. All right, so it's a very worthwhile thing there. But another instrument in there, again, is that Pixel one. It's Planetary Instrument for X-ray Lithochemistry, where litho is for rock, and so we're looking at the chemistry of rocks, but it really is mostly just to get the acronym to work to give you pixel. All right, so then you've got a fine-scale spectrograph, in other words, a high-resolution spectrograph to give you a bit more information for looking at those surface materials there, and the metals actually at the surface. Then we've got Sherlock, another fun acronym: Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. Sherlock. Basically, it's another spectrograph, but this one's ultraviolet, in particular looking for organic compounds. And by organic compounds, we aren't just talking about stuff that is in organic beings. Really, we're talking about carbon-based chemistry. When you hear the words organic chemistry, think carbon. So we're talking about, say, methane. That's technically carbon at its center, and so that is the most fundamental thing that would fall under the category of organic chemistry. Does methane come from biology only? No, but this is still referred to as organic chemistry as a branch. So when we're looking for organic compounds, we're looking for organic molecules, things made from carbon, and in particular, again, what they want to find, though, are the kinds that really can only be originated through biological processes. So it is a really neat process, but another neat thing they're working on is a drone. In particular, a solar-powered little helicopter with counter-rotating blades. It actually is just known as the Mars helicopter, and this is a model of or a model version of it. And a few things about it: it does have a very specific purpose. In particular, that atmosphere there is very tenuous, so we want to know, can you actually fly there? Can you actually produce enough thrust to actually fly in that atmosphere? And can we then use that to get some nice high resolutions from a different perspective, which will allow us to see all sorts of places we can't otherwise see, such as taking looks at cliffs, caves, deep craters, and other things that you can't go and drive into. All right, finally, though, with regards to those purposes, yeah, there's of course challenges. Again, the atmosphere there really reduces the overall thrust, so that first purpose, yeah, again, we're trying to overcome this challenge, actually generate enough thrust to lift up off the ground there. And it also has to do all this without any navigation aids from global positioning systems like what we have here on the Earth. There are a lot of different drones you can fly around. They can actually reference GPS satellites and other things to make sure they get to all their specific places. You can't do that on Mars because there isn't a global positioning system. You actually have to do that all yourself by looking around at what you're doing. And those takeoffs and landings have to be done in such a way that they can land on any given surface. Not something really steep, mind you, but it needs to be able to actually land on an unknown surface, not just on landing pads, as it were. Why would we want to do this? Well, there's of course many other applications. We want to use this as a scout to actually plan ahead on rovers, so that way we can also look ahead and prevent the kind of thing that happened to Spirit, getting stuck in a sand dune with its wheels eventually not working along those same lines. So it is a very worthwhile thing to have a nice scout, and again, reach those hard places, and it could also be used to carry payloads around. So how are we actually going about this? Well, I said it used counter-rotating blades. Let's see if we can actually get this to pop up here. Pushing the button. I hope it doesn't go like 5 slides ahead. Let's see. Can you help me out up there, Dustin? All right. We do have a video here. All right. There we go. So again, yes, this is really mostly about demonstrating the possibility of this technology on Mars itself. So it'll be a nice little thing. There's the counter-rotating blades. That ensures it does not spin wildly, and it also means you can actually have very relatively simple controls, and again, a stationary solar panel platform right on top of it. So this will allow them to image different places where you could not otherwise drive and get much higher resolution than you can get from orbit. And of course, that information could then be transmitted back to the rover and thereby transmitted back to orbit. They have done some test flights with this by actually putting it in a vacuum chamber here to show what we're looking at. Again, this is just partially built, but this is showing that it could actually work. And if that is actually really well set up, then they're actually still flying this in Earth-based gravity, which means it's definitely producing sufficient thrust, which is great. Of course, they might be compensating for that by actually using some counterweights. I did not get a chance to see all the details on that. But yes, this is a wonderful little thing, because if we can actually ensure air travel on Mars, that actually is a useful thing in general, especially if you don't want to just rely on rockets to get around. All right. So as far as, yes, this particular rover has not yet received a name, but again, you can actually send your name on this rover if you want. You can go to Send Your Name to Mars, and that'll actually do it. I have already signed up for this one, so my name's going on this one, so I get some more frequent flyer miles on this one. Got lots of points on this. All right, so yes, if you're interested in doing that, there's already, last I checked, over 6 million names. It's probably over 8 million if I had to guess. It's increasing dramatically from day to day. So if you want your name etched onto a chip that's being put on this rover, you can actually sign up on here. All right, so that's a great little thing there. But of course, there it goes again. Yep, it's freaking out. Let's see, back up. Other near future missions, this is the slide I want. We'll just leave it right like this. Yes, the Rosalind Franklin rover is being built by the European Space Agency, and it's being carried by a Russian lander. And this is really the European Space Agency's first Martian rover. This mission is what the Schiaparelli entry-descent landing module really was designed to ensure would work. Again, that mission that crashed due to the spinning and freaking out of the sensors, that is something they wanted to have happen to a technology demonstrator, not their rover. So that is why they actually considered that mission, again, a success. So that way, the Rosalind Franklin rover can actually be more successful. Now, the name itself, Rosalind Franklin was a scientist who was instrumental in the X-ray crystallography of studying the structure of DNA. And so this particular choice of scientist name here is to emphasize that exploration is in our DNA. So this is a great one that is expected to land in about or in the 2021 timeframe, around the same time as the Mars 2020 rover. So they will be jointly on Mars at the same time, though on very different parts of it. Now, again, this really will allow them to set the stage for more ambitious missions, which I've already hinted at. Those ambitious missions include a sample return mission. So how does that actually play out? Well, it plays out a bit like this. You have the Mars 2020 rover actually landing, going and collecting a few samples, leaving them somewhere to be collected. Then you have a successor to the Rosalind Franklin rover actually going over, landing on the ground with a nice, interesting lander, wandering around and going and collecting those things, taking them on back over to the launcher itself, putting them into a rocket there and having a liftoff from there, flying into space, getting nice and in-lined in orbit with the same vehicle that took them there in the first place. And actually, then they yell at each other to figure out where everything is. Okay, they're on course. They collect the sample and fly on back home. So that is the general framework for a European sample return mission as designed here. And this is really rather convoluted, which is why they want to be very careful to make sure they can do this. So that's why on the 2020 rover, they have that proposed sample collection and retention option to be able to actually send it back via another rover here. So this is really a good picture of one of the big next steps with regards to robotic exploration on Mars. But one more look back at some of the rovers that have been there. We have, of course, Sojourner and the Spirit and Opportunity Mars exploration rovers, and then Curiosity / Mars 2020 on the right there. And then we have Carl Sagan with one of the Viking lander models right there. So this is really what we're talking about with all these things. If that's the size of the Jeep, again, Sojourner was about the size of an RC car. So it's a great set of missions there, and they've been all over the place. This is what we were looking at here. Insight and Curiosity are actually over in nearly the same spot there. Phoenix Lander back up here, Viking over here, Sojourner with Pathfinder right about there. Then looking around, you also have Mars 3, our nice little 20 seconds of data being sent out there, and also a couple of failed ones down here, along with Mars 2 also not quite landing well. But then we also have, of course, the future with Mars rover, the 2020 rover, probably landing in 2021, along with the Franklin Rosalind rover landing relatively close to Sojourner. Again, this is a map of the entire planet of Mars, so we're looking at things rather widely spread out here. But that is a great view of all the exploration we've done so far on the surface of Mars, but there's much more to be done, because what comes next is getting ready to actually have humans get there. And there have been a few things along these lines to actually do a lot of preparation, and this year wrapped up a really neat challenge. That was the NASA's 3D printed habitat challenge, and the goal there was, of course, fully autonomous habitat construction. And this is, as they stated, the goal of this particular project. NASA's 3D printed habitat challenge is advancing the additive construction technology needed to create sustainable housing for deep space exploration, including the agency's journey to Mars. The competition is divided into 3 phases focused on design, materials, and fabrication. So as far as the design went, there were a whole bunch of wildly different designs, and then from the material standpoint, that was their second phase, where they actually looked at different ways to build things. Some used a lot of Martian regolith, all the rocks and stuff, to actually build up these structures. Others used more manufactured chemicals through polymers and such. And then final phase was actually out to have a test fabrication of some of these. And the final winner was a team by the name of AI Space Factory, and their design is what's shown on the right here. They realized that to simplify the fabrication process, it would actually be beneficial to have their printing robot be entirely stationary. And as such, yes, we can take some of the lessons we've learned here with regards to all these different rovers and such, and actually park one in one spot, have a nice crane that 3D prints this big old tower that would be about 5 stories tall, and the astronauts then would be able to live in there. It may not be ADA compliant, but the lower gravity there does help people get around. So it would be a nice thing to actually get done, and they printed a scaled down version of this in the last part of the last phase of the competition, which won them about $500,000 to further their research. So this is a great example of where we eventually want to take our robotic inhabitants of this rusty world. This is a wonderful thing to work towards, and we've come a long way in a very short time. Again, I said this was going to be an overview of a lot of different things, and yeah, there's so much that has gone on, and there's so much to look forward to. Thank you for your attention.